Friends, for the next 60 to 70 minutes, probably my interest is to highlight the challenges and opportunities, especially in the field of video analytics, keeping in mind machine learning and deep learning techniques. Today, what is really dominating is artificial intelligence, especially computer vision based applications. So if we can see and enjoy the nature, if we can see and observe and make some decisions, if we can see and generate some alerts for others to safeguard. So whatever, most of the activities which we do from morning to evening is completely governed by our vision applications. So we have a powerful natural gift by the God that we can see and enjoy, but on the other hand, if we think of inculcating similar abilities into computing technology, then we'll have to set up a camera and see that the camera will capture the videos, the our vision system continue capturing those data and exploring the beauty of available techniques called tools, and especially because of the existing deep learning architectures, how one can think of making our artificial intelligence in reality possible. So working towards realization of AI has really become a current requirement, not only in branch of engineering called computer science and engineering, but also in every branches of science in general, including medical sciences. So name any field of interest. What is really being supported is computer-based solutions, AI, especially AI solutions. So this machine learning and deep learning are really mattering a lot, and those two techniques have been taken up by researchers today for the development of autonomous computing systems. About computer helping is in only mathematical computations, and later on we realized that AI can play a role, and with the human interventions, with semi-automation, we can see that the computer can help us in most of our day-to-day activities, including teaching for that matter, especially for attendance taking and so on. Instead of going with an expert systems which really involve human interventions at every stage, today we are talking about completely an autonomous computing system. Completely autonomous in the sense that the systems are expected to behave like a human being, if not in general, at least for a specific domain. At least for example, of surveillance applications. If a building is being monitored by a camera, then irrespective of the corner at which some unauthenticated person tries to enter, then the system has to automatically generate and brings it to the notice of the owner of the building that there is somebody who is trying to enter into your campus. So we don't want to get involved, especially in monitoring and watching the videos being captured, but we want the system to take up the signals from the video and split it up into number of shots, and then identifying a couple of objects present in it, and then predicting what is the possible behavior. And based on that, if the system can let us know that what is happening in reality, perhaps that could be used as, if not, definitely not as a complementary, but as a supplementary solution, as a kind of assisting aid, so that I become more efficient and effective in my day-to-day life activity. Keeping in this mind, Dr. Shekar and his team members have really thought of a wonderful FDP program entitled Machine Learning and Deep Learning for Video Analytics, because video has come to that level of understanding. Video has started playing a wonderful role than even images, because video is a collection of 2D images, of course, with an added dimension called time axis. So video analytics is really of great importance, and I'm sure that down the line for the next 5 days, so having attended perhaps the marathon lectures by eminent scholars, good speakers who really speak, with their background of experience, who would help you in picking up good problems to research further, and would also help you knowing what are the real opening issues, right? So generally, when we read some literatures, probably we have got an illusion that things have been well solved, even including face recognition. Things have been well solved, but still, face recognition is still a challenging job, especially when you think of deploying the solution for real-time applications on video basis, right? Not on image base, but on a video basis. Especially not in a small circle of a school or in a university, but when you think of recognizing people in airports, recognizing passengers in railway stations, identifying somebody who is really not permitted to enter into the campus of a large population, it becomes a very tough job, right? Okay, so there are many issues which come across. It's not that deep learning architectures would always help you in just setting up the system, but which deep network really works wonderfully well for a specific domain, and which works fine when the day is a sunny day, which works fine when day is a winter day, cloudy day, etc. But because no deep learning single alone will work for all possible environmental conditions, then doing certain research and then personally tailoring up the existing deep learning architecture so that the system starts working in different circumstances and different lighting conditions, with different obstacles, sudden appearance of such different obstacles in environment. Ultimate job is, if I stand to monitor an environment, right? If I just look at and monitor the environment continuously for a day, irrespective of the lighting conditions and environmental changes, why not my system? If that is the problem, then how to deploy, how to make use of tailoring of available machine learning and deep learning tools so that the system starts behaving like a human being for a specific domain. So these are all quite interesting applications for budding technocrats to pick up and contribute a lot. Keeping this in mind, I just take you all for a quick walk. Though I was supposed to start at 10 o'clock, it has got already delayed for about 45 minutes, but within the time given to me, probably by 1 p.m., I'll try to go for the walk which I decided, highlighting you or showing you various corners and opportunities to pick up some good problems to work on, and thinking of contributing in your own way to the literature of machine learning and deep learning. So let me begin with the definition of an intelligent, because the ultimate job of a computer scientist today is to make computers intelligent. Of course, computers have become so intelligent, day by day they become smarter and smarter. But how to make the system intelligent? What really matters is AI, right? So it is an ability to solve a problem. Given is a problem, I want the system to automatically think and learn about the problem and get to the solution, right? So it is its capacity to learn and acquire knowledge. But ultimately, if I being a person, I being a professor of computer science, don't like the system to just end up acquiring the knowledge. But I expect the system to, even after acquiring knowledge, to make use of the knowledge so that the system becomes experienced, system. Like I say that I have got 25 years of experience in teaching and research. Similarly, the system one day should say that I've got an experience, 2 decades of experience in AI and so on, right? So how to make such a self-learning system? So that is really challenging, and ultimate the target is to introduce a kind of competency in the computing system to make use of the knowledge so that the computer can automatically interact with its own user. So probably, if I recollect now with your support, hope you studied, we all studied in our school education that, a couple of animals called domestic animals were cuddled by our ancestors, and they were given a specific training, not a general purpose training. Please remember here that this could be a good analogy to understand why we are talking about more specialized computing entities today. So when soon after civilization, man wanted to do better and wanted to accomplish things efficiently and effectively, But when he wanted to be more efficient than what he was earlier, then he thought of making use of the support, taking up the support, help from other good friends and family members, and beyond that, why can't we take up support from the animals? Then he could catch out of a couple of animals which we can as domestic animals like oxes, which were given specific training for cultivation, right? The oxes were not given training for riding or for carrying goods like donkeys, but oxes were given a specialized training for cultivation. But on the other hand, look at this picture where the donkeys are trained for carrying goods, right? Carrying goods. So whereas the dogs were generally, even today in our residences, we got dogs. Put a label that be careful that there are dogs in my residence. Right. So why the dogs were given such a specialized training, and police people are exploiting the ability of dogs in finding out person who has committed a crime. So dogs are specially used for a specific domain, unlike donkeys which are used for carrying goods. Dogs are not used for it. Right? Dogs are specially trained for a specific application. Horses, on the other hand, used. Even today we enjoy horses, right? So look at what do we understand with this, what do we understand with this is that, every animal which we generally consider as a domestic animal was given its training and a specific domain. I mean, no animal was given such a training so that the animal can be used for general purpose. On the other hand, except the human being, and no other animal can be, of great support for all applications. Every animal was supportive only for a specific domain for which it was given a training. Similarly, today, instead of giving such trainings to animal which possess natural intelligence, why can't we think of giving such as training to a non-living entity called computing systems? That's what is called artificial intelligence. Artificial intelligence is to make computers exhibiting intelligence. So any simple programming, writing up a program to decide if a given number is even or not, and if computer can do it, then I say there's certain degree of artificial intelligence in the computers, because computer decides whether the given number is even or not, right? The moment I type in the number 4, it says it's an even number. How does it say? Because it has got some intelligence. That intelligence is because of programming. If you explicitly program that so that the computer starts working for you, then I say some degree of intelligence has been inculcated, right? Beyond that, we make the system think and look for something and get me the data of my interest and retrieval of data and so on. I mean, ultimate job is to somehow program a computer so that it simulate or mimic a human intelligence. If that is the case, then I call it as artificial intelligence, right? Earlier we were talking about sorting, searching, reasoning, planning, whatnot. Expert systems were there altogether, helping us in most of our day-to-day activities. Okay, so I mean, the general purpose computing systems have started becoming personalized computing. Computers were dedicated for commerce purpose, were dedicated for economics purpose, were dedicated for only surveillance applications, dedicated for assisting doctors, in making up some decision based on the data fed into the system. And such computers are called personalized computing. Okay, earlier when we started our bachelor education, the computers were defined to be a general purpose, but today the computers have become more personalized entities. So, instead of explicitly programming a computer, why can't we think of, seeing that the computer learns on its own, the way in which human beings learn? Please mute your audio. I request all participants. Hello, Dr. Shekar?
Yes, sir. It is mute now, muted now. Yeah.
Please mute every others, right? Unless I want them to interact with me, don't give them a permission to unmute their audios.
Yes.
Okay, am I audible?
Yes, sir. It is very clear now. Going on there.
Okay. So instead of explicitly programming a computer by stating every statements and so on, why can't we think of computer to learn looking at some examples, right? That's what is called machine learning. So instead of writing up a program to check if given number is a prime or not, then we work with a sequence of instructions where number is read, and then we try to divide, that number by any other number other than one and itself. If any such number exists, dividing it successfully, then declare it as non-prime, otherwise a prime. Instead of that, can we think of collecting some examples of prime numbers? Collecting some examples of non-primes. It's even today a challenging problem for machine learning or deep learning, researchers. Can we automatically think of a classifier which will learn on its own by looking at some examples of primes and some examples of non-primes? Still, problem is not yet attained. You can try to solve this. The problem is now I have certain, like 30, 40 prime numbers, like 7, 19, 41, right? 37, 91, some numbers which are prime, and I have got some numbers, another 40 numbers which are composite, I mean non-primes. If I give these 40 plus 48 together as examples, telling the system that these are all primes, these are all non-prime, then I want the system to automatically learn that these are all the numbers which are divisible by any other numbers, whereas these are all the numbers which could be factorized by other prime numbers, right? Can the system be made such intelligent to learn primes, and how are those different from non-primes? If that is the case, then I say that it is a machine learning. Ultimate job is some more. Given are the examples, given are the samples of my interest and associated labels of those samples. Instead of you letting the system explicitly know how to solve it, can I simply declare that I want you to work on this, classifying them as class 1 samples, classifying these as class 2 samples, without explicitly programming a computer. And that is what is today called machine learning. So it is an approach to AI. I mean, ultimate is to inculcate intelligence in the computers. It is to make computer learning, right? It's not that you program it so that it attends to your program. It's also a self-programming, right? Learning, extracting knowledge out of the samples available and making use of that knowledge for subsequent decision making. So we are talking about pattern classification, clustering. Not today. We have been talking about these issues for the last 40 years. But still, it's an opening question because of the size of the data population, right? Earlier we used to work on a smaller pieces, but now we have to work on a big data, big corpus, and that's the problem, right? Look at here on the right top of the slide, you would see that different stages of machine learning. A classic machine learning, given our some samples of interest which will be fed into some pre-processing which decide the quality of the pictures of the video, and then some region of interest will be extracted, out of which the features are extracted, characteristic values are extracted. Features are nothing but some values which characterize the given sample, right? So that one sample is distinguishable from other samples of different classes. So extract the features and then selectively choose the best features for keeping the system more efficient and effective, and then organize them in a library. So index them so that fast retrieval is possible, and see that the classifiers will learn about this and create the library, and finally it will generate what we want in the subsequent task. That's what is called a machine learning, right? So the moment machine learning came into picture, the computers which were earlier generated have become personalized, and now the personalized computers are becoming more specialized computing entities, right? So personalized means the computers can serve whatever I want, not somebody's. But now the computer is not only serving all what I want, but only a special domain of my interest. That's what is called specialized computing technology. And today, because of the existence of deep learning architecture, a powerful teacher, I would say, teacher in the sense that somebody should instruct the learner to learn. Similarly, here we require some tool to initiate learning on computers. Deep learning architecture, deep learning tools opportunity such a powerful teacher where it initiate computer to extract features on its own, and looking at the labels of the samples given, the system can automatically decide which is the best features to recognize, which is the best features to characterize each sample, so that subsequently the labeling process becomes simple. So that's what is called deep learning. So deep learning avoids, it will keep you away from feature engineering, whereas in classical machine learning, so it is our responsibility to think of the most suitable feature extraction scheme. So if there are n number of feature extraction scheme and if there are m number of classifiers, then we are going to we are going to think for crossing of both possible and then find the best combination of feature extraction and a classifier. Instead of here, if you have decided that there is some neural network classifier and I want these all to be labeled as 1 and these all to be labeled as 2, then the system, the deep learning architecture automatically learns, what is the characteristics which are common across all samples of class 1 and all samples of class 2, which are not common across any sample of class 1 with that of class 2. So then that's what is called deep learning. See, we do the feature extraction and then feed into the classification to get what we want. That's where the problem was earlier. That's where the ambiguity was, that where the dilemma was, right? The complexity was in conventional machine learning. But in our deep learning architecture, you need not have to worry. The only thing what you have got to have a distribution of input and output samples. No input, we have samples, and output, we have labels. And what is the distribution? You just feed the distribution, telling the system that this belongs to one class, this belongs to second class, and so on and so forth. And the system will automatically learn on its own the best characteristic, value features, so that classification becomes really wonderful. So that's what is called deep learning today. I mean, the system is expected to have a deeper understanding. Okay, earlier we used to have a superficial level understanding, and based on that, we used to decide. Obviously, that doesn't work for a large corpus. Now, deep learning can learn into a deeper and dig out more information so that the system becomes more knowledgeable for. So the system will have more information for effective decision making. So if I touch upon a setup of machine learning in general, as I already told you that basically we have 4 components. One is called as input sample space. The other one is called a label space. I called output space, and we have a distribution, mapping from input to output. What is supposed to be labeled by what? That's what is called distribution. And then we have a loss function. This loss function means the difference between what is expected by a computer and what is given by a computer, right? How much is the deviation of the computer result from the expected one? The ultimate job is to reduce that deviation, right? That reduce that gap, and that's what is called a loss function. So the task of machine learning is somehow to predict such a hypothesis which minimizes this loss function. I mean, so given are this mapping of x onto y, x cross y, right? Suppose in case of image recognition application, given is a picture of a dog, I want that to be labeled as 1. Given picture of a horse, I want that to be labeled as 2. Then I have some examples of dogs, where dogs with a different color, dogs with a different shape. I mean, dog sleeping, dog jumping, dog running, dog walking, and we have different samples of dog classes, and similar differently many samples of class. And I want all dog samples to be labeled by 1, all R samples to be labeled by 2. And just I simply mentioned that for these samples, assume that each picture is of 100 by 100, 10,000 pixels. Then what is input dimension? The input dimension is 10,000 values. And that 10,000 values of one image has got to be given as input. Correspondingly, the label has got to be generated. Then output is only yes or no, or 1 or 2, or 0 or 1, right? Or you can say -1 for a dog, +1 for horse, and so on, right? So then given is such a mapping, 10,000 dimension vector as input, so many values, and expecting only one value to be generated. And I just work out that mapping for all samples which I have got. And looking at those, samples and mapping, the system is expected to predict which is the best way to categorize. And that's what is called hypothesis. So we have to predict the best hypothesis. I mean, here is H is a space for searching. Where I get to? What are the possible hypotheses, right? As I said, in case of conventional, I mean, classical machine learning, I got n number of feature extraction schemes. I got m number of classifiers. Then, crossing of them, I mean, n into m possible combinations I can try out. Then out of that, which is the best way? Anyway, in classical machine learning, I am restricted to only n into m possibilities, right? Because the parameters are reasonably less in case of conventional classification or conventional machine learning. So here I'll have to look at all possible solutions. Out of all possible solutions, which is the best effective solution, which is acceptable. I mean, look at here is a search space where I have to search for a solution. In this search space, expected ground truth, ground hypothesis available here. This is where the point I have to hit. Unfortunately, I may not end up with this hypothesis because I end up in another corner of the search space, right? Because basically it is an optimization question. So while searching for hypothesis, I may restrict myself to only a subspace of that hypothesis space, because looking for entire hypothesis is practically not possible, because I work with finitely many parameters and not with the infinite space. Obviously the search space gets compressed to some restricted to some region, and then that actual expected ground hypothesis may not be an element of it. Then however I try, it's not possible for me to get into that, right? But on the other hand, I may expect this to be the actual outcome of my searching algorithm. But in reality, it may so happen that instead of arriving at this, my computer may end up computing something different. Let's call it as HC, and that's the difference. This difference is what is called an error, and this difference is what is called another type of error, right? So the computer may expect, because of my computer also has got certain limitations, the actual output could be this one, right? Computationally, I can look for this. This is what is my expectation theoretically. Computationally, I can look for it, but because of some limited resources, actual output could be this. Again, there is another difference. These are all the three different types of errors we get to minimize. One is an error called approximation error. One is what is called overfit error, right? One is what is called ultimately error in and the output generated. So look at, these are the three different errors which we have to optimize, which we have to minimize. And looking for such an hypothesis which minimizes all these three errors is what is basically a task of any machine learning algorithm, right? In general. So if I step into classical machine learning approaches quickly, then as I told you way back, that the classical machine learning algorithm will require some samples, and those samples will be subjected for some enhancement operations so that the quality of the samples will be improved. So once quality of the samples are improved, then we go for some finding out the regions of your interest, because the entire scenery, entire image or image video frame may not be great importance, right? To recognize the face of a person, you need to look at the background. You just take away the background and try to crop only the face area. That's what I call it as segmentation, and do certain segmentation. One segmentations, look at, there are possibly many segmentation algorithms. There are possibly many different enhancement techniques. Which enhancement technique really works better for my application? That is the research today, right? On the other hand, which segmentation algorithm gives me a more accurate way of segmenting, cropping out what is my area of interest, what is region of my interest, right? So there are many segmentation algorithms. Assume that there are, n1 number of enhancement techniques and n2 number of segmentation, and there are n3 number of extraction techniques, right? Like color features, which color space works better, right? So which D features work better, which texture features work better, and so on, which are the best, image descriptors. Try out. There are, assume that n3 number of, possible algorithms, and then dimension reduction. Do I really require all thousands of features which I extract? Can I selectively choose only few out of several so that the system can work much more efficient than faster than the earlier, right? So which dimensional techniques look at? If there are n4 number of dimensional reduction techniques, then the possible combination turn out to be n1 into n2 into n3 into n4, a huge number. Practically thinking of all possible combinations and seeing that you feed the samples and train the system and predict its accuracy, calculate its accuracy and other performance measures, and based on that you decide which combination. You will never attain a solution at all. During your lifespan, you will never attain a solution, right? So look at, on the other hand, the deep learning is the one which keeps this complexity totally away from us. We need not to worry about. That's an advantage of deep learning. So anyway, so once dimension reduction techniques are employed, the size of the feature vector is reduced to some minimum, and then we initiate a learning model. For learning model, on the other hand, I have to feed in some labels of those samples. what is what? That's a question, that computer should be given such information that, which sample is of which class. So that class information, that extra description about the samples, labels will be given by the domain expert. Look at here. We're all computer scientists, but start working on medical images, classification of medical images. Then we really require medical doctors, to help in labeling of those samples. So I wanted to work on, some flower classification. When I attempted to work on flower classification, because I'm no way, connected to flower and their species, though I could collect roughly about 100 and plus different species, the samples of so many species, but unfortunately I could not end up generating the label. The reason is that I am no way connected to the flowers. Then we approach the botanist. But what is the guarantee that the botanists are equally, interested in your applications, in your methodology, right? So look at that's really changing today for people who work on machine learning. But on the other hand, we talk about Google. Google, has released a new product, etc. Because we have become a member of Google in one or the other way, either in one or the other apps. The moment we feed in our data, the moment we give our samples, the Google, will take all those samples and use them for training the model. So that's what domain experts, their participation is very important. We cannot simply neglect their, importance. So learning models will learn. It takes input from the domain experts and also our, feature extraction scheme, and then associate and classify. It does clustering, classification. I'm sure that in one or the other day, next down the line, for about 4 days, off a day is dedicated for explaining you what are the different classification algorithms available, what are the different clustering strategies are available, what is what, how is it different from other, which sounds better, right, under what circumstances. I'm sure that one of the speakers would highlight on different classification algorithms and clustering techniques. So, and then, if the corpus happens to be large, at the time of recognition, I cannot go in a sequential search. If you scan the library of your knowledge in a sequential manner, probably you will end up with a worse time complexity of taking up a longer time to make up a decision. By the time your task will be over. That should not happen. Then I have to index this database so that a faster search is possible. I can get the data of my interest as early as possible. So that then we are going to use suitable indexing strategy to index your library so that faster access is possible. So then you just put all along with the samples you collected and along with their annotations for future usages. Then that what I call it as a corpus creation. So this is how we do in classical machine learning, right? Look, everything is in your hand. Nowadays we are talking about, instead of giving this pre-processing and segmentations for the system itself, why can't we think of, because today we are talking about mobile based applications, right? My cell phone has very good camera, and this cell phone can capture not simply an image, even a video, right? A quality video. If that is the case, instead of capturing the video and sending it across, cable for the system to do process it, and then why not this mobile itself has some app so that it does some edge computing, right? Edge computing would help us in minimizing the data transmission. The moment you minimize the data transmission to the system, obviously the system works faster, right? So that can we do certain edge computing on the mobile itself? That is another opening issues for the budding technocrats to take up. You need not work on deep learning, for deep learning comes at the second stage. Even what best we can do for enhancing the quality and what best we can do for extracting the features in our mobile cell itself, so that I need not send the image data, I need not send the video data across. I can send only the values called real numbers, right? Only integers or only real numbers, right? Non-negative integers, non-negative numbers. So that's good enough, right? So that would speed up your activities. So generally in classical machine learning, we go with this type of to name few, I've taken up 3 classifier like decision tree ensemble, support vector machine, least square regression, which generally are assumed to work in an Euclidean space, right? But in reality, the human brain thinks beyond Euclidean space. But computing, this is where you see a big gap in understanding between the user's expectation and the computing's ability, right? I mean, there is a big gap. My expectation is totally different. The way in which I solve the problem, the way in which I attend to the problem is entirely different than the way in which the computers have been programmed, even in machine learning, right? Using machine learning techniques. So because in machine learning techniques, generally we assume that the system works in Euclidean space, classification is happening in Euclidean space, but human brain thinks beyond Euclidean space. Such a gap existing between the system's ability and user's expectation is what is called semantic gap. Any sincere attempt towards bridging up such an existing semantic gap, right, could be really a noticeable contribution in the literature of computer science, especially in machine learning. So linear hypothesis space we have, I mean, there is a weight matrix W and there is an input matrix, vector X, and to multiply them, then we expect that to be a scalar quantity or a vector which helps us in quickly deciding the label of the sample X, right? So least regression, square regression always tries to fit a linear segment, whereas in case of decision tree ensemble, we use more number of thresholds to partition the space, right? Again, it is a linear. In support vector mission, look at here are some examples of class 1 which are blue in color, of examples of class 2 which are green in color. Ultimate job is to draw a line separating these two classes, so that with respect to that line, where does my next unknown sample belong? If it lies to the right of this line, then I say it is a class 1. If it is to the left of the line, then I say it is a class 2. I mean, which is the best? What is the slope of such a line, right? What are the parameters of that line? So is it good to have a line here closer to this, or is it good to have a line here? No, it's good to have a line which keeps both the classes at as far as possible, at a larger distance. I mean, maximize the margin, then take up the mean of that. That is how the support vector machine learns on its own, looking at the characteristic values, I mean, the features of these samples, right? So, but still, I understand that it is a linearly classified, but not all classes are linearly separable, right? The boundary which separates two or many classes may not be linear, then I have to approach that non-linearity by a sequence of linear, piecewise linear, right? That's how the neural network really accomplishes a non-linear boundary also while separating two classes. So this is a conventional machine learning. Whenever I understand that the features which are extracted are not so rich in discrimination, right? Because the samples of different classes get merged together in the feature space the moment I extract some number of features. Kernel functions can be used. These kernel functions will try to map these, features in a feature space which are merged together of different classes, so that into a higher dimensional feature space, so that they become separable. So such functions are called kernel functions, which are generally considered to be nonlinear functions. For example, here, look at, there are two samples of two classes. So, but the classes samples are separable only by a nonlinear boundary. Then the task is to map these samples onto another space of same dimension, such that I can draw a line separating, a linear segment separating samples of both the classes. What is that transformation function? That is what is called a kernel function. In this case, the kernel function maps you from n dimension to n dimension only, maps you to a space of same dimension. But most of the times it doesn't work. Certain times, however, if we try and it is not possible to map it onto only 2D in this example, right? In the second example, look at red dots are completely covered by the green dots. So then the better way of separating this red from the remaining is to give them added a dimension, third dimension, so that you just pull them up. The moment you pull them up, you can draw a surface separating all reds from green, right? I mean, you have moved from 2D to 3D. You have moved from some lower dimension to higher dimension. Most of the times in classical machine learning, we talk about dimension reduction technique, but we generally neglect about dimensionality enhancement. The kernel functions are such examples which would enhance the dimension of the samples, right? Feature dimension gets enhanced, right? Gets boosted up so that separability is possible. Once separability is achieved, then the best thing is you get these red dots projected onto third axis, which you have recently introduced, and get these green also projected onto the same axis. Then you can think of a threshold here at this point, which separates values of red from that of green, right? Again, you have got them reduced to single dimension. Look, originally your feature space is the 2D. But however you try in 2D, you cannot distinguish red from green. Then the best thing is to map them onto higher dimension and see that they are separable, and then get them mapped onto a lower dimension. Suddenly it has been reduced to single dimension. That is the beauty of the kernel functions. You can exploit the beauty of kernel functions for achieving reduction in dimension, not directly reducing, but via enhancement. So once you are done that, the library of database is created, then at the time of recognition, an unknown sample is given. It could be a video short, which is given. Then you do the similar pre-processing, similar segmentation and feature extraction, same features and apply to a dimension reduction, and then go for a classifier which has been trained well using certain examples. Right now, the trained classifier is expected to generate expected label for an unknown sample. That's what is called recognition. That's what is called relabeling, right? So look at that, learned corpus is used along with its annotation, and finally the top k matches will be retrieved along with their matching score, and based on your interest you decide whether you go with a rank 1 or you go with a rank 2 or majority 1 out of top k, right? You just later on you can decide. This is how the second phase called relearning, second phase called recognition is happening in classical machine learning. Okay, so again, even if you could do that, pre-processing and segmentations on mobile devices to speed up your activities, even you can think of similar on mobile devices, even at the time of relabeling or recognition. So unlike these classical, machine learning approaches, deep learning appear to be totally different, right? Because these deep learning systems will help us in getting all such dilemma resolved. I need not to worry about which is the best feature extraction scheme, which is the best, classification algorithm. You just decide which is the classification algorithm you want and tell the system that these are the samples of one class and these are the samples of another classes and so on and so forth. There are n number of classes and these are all, supervised learning, I call it. If you are aware of the labels of all samples and if you have sufficiently large number of samples, so that the system called deep learning architecture can learn more and more in a deeper way, so that classification tasks can be solved efficiently and as well effectively. That's more important. So we have a gallery of deep learning architecture today. So like starting from fully connected network, which was exploited only for classification, not for engineering, moved on to conventional neural network, which integrate classification called fully connected network all along with a convolution operations, which would help but automatically extraction of the feature of interest. And then we have recurrent neural network, which would support us in getting into the problem associated with the time axis, especially for video labeling. I wish you go with RNN. If your frames are mutually dependent in a sequential order, if the label to be generated for the 10th frame case is depending on the sequence with which the earlier frames have appeared, right? Then you go with recurrent neural network. Otherwise, you can go with any convolutional neural network. So there is a gallery of deep architecture today. That has really, again, put us back into the same confusion. Earlier, we used to worry a lot about, we used to face, real difficulties in selectively choosing the best feature extraction scheme and best classifiers, right? And their combinations for effective classification. But then later on, the moment deep learning tools have started coming up, we were happy that certain things have been automated. So I'm now away from all such dilemma, all such complexity. And when the research continued toward that, today we have a gallery of deep architecture, AlexNet, ResNet, variants of ResNet, right? Variant of ResNet. So YOLO for detection, object detection, SSD for object detection, right? Mobile YOLO, right? YOLO versions. Where are variants? We have several now today. Which is the one best suits my domain? Which is the one which could be deployed directly? Which is the one which has got to be tailored up so that it suits all environmental situations, right? So that is another interesting job today. We cannot simply think that deep architecture is available. Anything can be automated, with a deep architecture. No, you can automate it, but you cannot deploy it in a real application so that AI can be made really possible. So that's deep architecture. So what I explained, what I said is that, initially we wanted system to inculcate a kind of, system to, learn something so that intelligence is possible. So machine learning has become a vehicle to do that, and deep learning has become a much more faster or an effective tool to accomplish machine learning. Look, on the other hand, Jeffrey Hinton one day said that deep learning is an algorithm which has no theoretical limitations. Wonderful. Which has no theoretical limitations of what it can learn. It can learn anything for that matter. That's what generally we claim that. And the more data you give, the more computation time you provide, the better it is, the better it does, right? That's what I mean. The job of a researcher is to collect the data, more data, label data, not only collecting, but also cleaning it up. Not only cleaning it up, improving the quality. Once if qualities are improved, then you have to have suitable labels, not misleading labels. So domain experts involvement is really that. Oh, those are the opportunities for us and challenges also equally, right? Look, data quality is very important. Never cleaned. I'm good at collecting data, but not necessarily a good data, quality data. Never clean. More time is spent on cleaning and preparing. Now we are thinking of can that cleaning and preparing be automated with a deep architecture? Or if not, can think of some AI-based expert system to clean up the data available so that the data population, I mean, the corpus could be filtered out to a quality version. So data quantity, how you use that? I said, more the data you provide and more computation time that you can provide to the computer, the deep architecture can do better. What do you mean by more data? When do I say that it is good enough? When do I say it is sufficient enough? Right? What are the parameters of the samples to be collected so the system can learn all possible behaviors? So this is what use requirement. Where? How to get it? Who will provide it? Right? So on. Data labeling, domain experts, their involvement, right? You have to initiate because all domain experts may not be so interested in your application, right? In your interest. Data explainability, confidentiality of the data. The moment you automate everything, where is the confidentiality of the data? Okay, so investment. Who will invest for all this? These are all really challenging. And am I thinking of complementary tool or a supplementary tool? That's more confusing. But take it from me, friends, that we are not looking for anybody to be replaced. We are not looking for a tool which can replace a doctor. We are not looking for a tool which can replace an engineer. We are looking for a tool which can assist an engineer, which can assist a medical doctor so that they become more efficient in their activities. So that's, I call it as a supplementary tool, right? So high expectations. People are expecting a lot today from AI, system, AI system. So look, there are many problems, but don't carry them on you above a shoulder. Better you just ride on them so that it becomes opportunity, right? So remember that most of the tasks do not require deep learning. Just because deep learning architectures are available, you should not think of always deploying deep architecture. And there is nothing like fully automated. You have to think of semi-automated most of the times. All models are not true, although some are useful. Just because some are useful, don't carry an illusion that every deep tools are really true. So faithfulness on outcome of AI tool, explainable AI. Just because your AI says that this is label 3, this sample belongs to class 3, should I believe it? Right? Why does that classify that it belongs? That is another branch of AI, another branch of what is called machine learning. Okay, so that why does system take up that decision? So that's what is called explainable AI. Explainable AI means that given is an input, there is a deep architecture, there is a learning architecture which generates the label. Given is my photography, it says that it is Dr. Guru. Now, should I believe that he is Dr. Guru? Because I am not aware of who is Dr. Guru, right? My surveillance application is monitoring, and the image of Dr. Guru is given to the system. System was trained fine. But when Dr. Guru steps into my campus, the system says that he is Dr. Guru. But should I believe it? What is the guarantee that a non-Dr. Guru, somebody who is not a Dr. Guru, is recognized to be Dr. Guru? On the other hand, if I ask somebody as security guard who says that he is Dr. Guru only, and if you ask him a question, why did you say he is Dr. Guru? On what basis do you say Dr. Guru? He explains, he explains. These are the things which I observed when Dr. Guru stepped into our campus. Last time he came along with so-and-so professor and they were talking, and I also remembered the voice, the audio, etc., the gate, the style with which he walked. I mean, he's not only looking at the face, he also looks at some association. Can you think of having another deep architecture in parallel which tries to reason out every stage in decision making of other neural network? other convolutional neural network, right? Here is one CNN which works for the level, and here is another CNN, which tries to reason out each step in generating the result of another neural network, so that this second neural network generates a paragraph which gives an explanation about what has really made the first convolutional neural network to come out with such a decision. That is what is called explainable AI. I don't want system to just simply see, for example, when you go to a doctor, it's for some medical treatment. If doctor diagnoses you to be infected, then you will ask him, what has really helped you? Why did you make such a decision? Otherwise, I go with a second decision, right? Second opinion. Even when you go to second opinion, you will interact with the doctor. Doctor then explains you the reason why he has taken such a decision, right? Similarly, here I want neural network not to just generate the decision, ultimate label, but I want neural network also to explain me this is the reason, right? This is why I have taken up such a decision. That is what is called learning a lot. Of course, global, but local to global, right? I want every finer details, and every finer details have got to be assimilated at higher level, so that, of course, system has learned a lot in a deeper way, but can I think of assimilating the deeper understanding so that I can generate some kind of explanation about the decision making, about the reasoning of judgment. That is what is called the branch of AI called explainable AI. So any contribution, any simple contribution, because the new area of AI, so simple contribution will get you a big reward for your contribution to the literature. So opportunities and challenges due to COVID-19. So as while I was on sabbatical leave associated with nanotechnology, working on real-time applications, I happened to supervise a couple of interesting projects, live project indeed. So probably in the month of, if I remember, last December or mid of December to January, May, we deployed a wonderful face recognition model for an organization which had about thousands of employees. So face recognition system was deployed well for thousands of subjects. Subjects means people, and trained on faces without mask, because there was nothing like COVID-19 situation in the last December and January. And we used deep learning tool. We extracted 128 features, deep features. And based on those extracted 128 features, we trained our conventional support vector machine to be, name it. The system was really working fine for all thousands of employees without any misclassification, right? But the system was working on video analytics. It's not that every person was expected to come and give an image, and that image will be like, no, the people used to walk in. While walking in, there is a video camera which continuously capture, and the best view of that man has got to be figured out, and that best view should be given to the system for recognition, right? Not only one view will be recognized to take a decision, and subsequent 3 or 4 views will be captured, and that will be injected to the system, and then the system is to take a total decision, combined decision, to say that he is Mr. X, right? And because of that, the system wonderfully was working fine. And soon after this COVID-19, probably in the month of March and April, system used to generate a wrong misclassification. The reason is that the system was trained for the full face, and because of this COVID-19, people started entering with mask. When the people entered with mask, the system used to then how to solve this problem. But we never asked the persons to again, give their face along with their lips, right, and with the mask, so that the system can be retrained. No, we could not. We wanted the existing system to continue working fine. Then suddenly we thought of feature engineering, right? Though we exploited the beauty of deep learning, but again we shifted back to classical feature engineering. We did a kind of subsetting, feature subsetting. Out of 128 features, which are the features which are responsible in preserving the details of only the forehead and eye area of a person, and which are the features which are responsible for remembering only this covered area? If we can throw away these features which are responsible for the bottom part of the face and keep only the features which are responsible for the top area of the face, probably I can see that my system can continue working fine even after COVID-19 situation. Then we just I'm sure that some touch upon different approaches for feature engineering, feature selection down the line. So my keynote lecture is just to assimilate, just to highlight possibilities what you learn for the subsequent 4 to 5 days. So I'm sure one of the speakers will take you with the different approaches of feature subsetting, feature selection, right, whatnot, and so on. So we worked on different data sets of large corpus and so on. And of course, we tried, again to tune up our deep architectures like Inception, Resonate, MobileNet. We tried all, and then none worked fine because see, there is an error. There is an error for any ratio of training and testing model. Then we wanted to tailor it up. That's what I said in the beginning. No existing tool, though appears to be working fine for your domain, for your data set, but now none of them could be deployed in a real time. No one solves your problem 100%. Then is you search for the effective one, search for the best suited one, and tailor it for your environment. That is where you require a kind of edge computing. You require a kind of a smoothening of your operations, right? So that's what we have done in this case. So feature subsetting, we just look at this. This phase was given for at the time of training a model, but this phase is given now at the time of recognizing a person. How to expect? Even most of the times, our vision system, our own vision system would go wrong. How can I expect my AI tool? And if this is a kid, this is a kid named X, and if this phase is identified to be the kid named Y, and you are assuming that Mr. Kid Y has entered the campus, and that gets recorded. If something goes wrong today, then this kid X will not be caught, but Mr. Kid Y will be caught, right? How do I believe? Why should I believe at all? The decision taken by the AI tool, right? That's what I said. Explainably, I want reasoning also, right? So look at this. This is actual fees, of a person which was given for the training, and later on, this is what the fees to be used for recognition. Still, system is expected to work. This is what the challenging. And because of COVID-19, not full phase is available. Only a part of the phase is available, right? So face recognition earlier about working with 128 features, and we just have selected feature subsetting and then trained it up, personally trained up, and then redeployed the system, and system started working with 100%. Finally, we felt extremely happy by the end of April, right? The problem started appearing in the mid or 20 plus of March, and we felt the problem, and by the end of April, when somehow we could tackle the problem and started 100% solution. So face recognition system was deployed with all these, and alternative models were also tried out. I don't have enough time to explain this, but I'm sure that one who will speak on the deep architectures will speak more on these issues. So some more related to face recognition could be selective the best view. I said, when person walks in front of the video camera, video should not initiate recognition of face for every frame. Then they selectively choose only the best frame. Which is the best frame, right? On what basis do I say which is the best view of a person, right? Okay, that. So how do I predict? Is it a right view? Is it a left view? Or is it top view or a bottom view? So these, view classification should also be done, right? So gender classification will help in real search, near search. I want in my campus or an instruction to be given to only those who are males. I don't want the instruction to be shared across females. And I recognize only the male gender classification in real time in video applications, right? So a person is watching, then you have to quickly label female or male, right? So age estimation, looking at the face, you have to say whether he's old or young or kid, so senior, middle, and so on. Work out your own. We worked on 6 different classes of ages, 6 different levels of ages, and we could deploy a system in big industry, big organization. The system works recognizing, not only recognizing the face, also predicts the age and interval type, right? And then expression identification. Online classes, especially, I just quoted it interestingly in the bracket because I wanted to say that though you are many participants, signed into our system, what is the guarantee that you are now listening my lecture? In order to make sure that, or in order to make sure that you are alert and attending my lecture, that Dr. Shekar or any of his good friend have to continuously watch your videos being displayed on a big screen. If you are thousands of people attending my lecture, there will be thousand smaller windows to be watched. Then he has to have across all walls of his room, many screens, That should not happen. Instead, and number one, that's another problem is if you all of you start sending your videos continuously for about 1 hour lecture, look at the bandwidth, look at the network, congestion. Instead of that, can you think of having your own app running on your mobile, running on your computers where you are logged in, signed in, right? So then, whenever you are not my lecture, like in the offline classes, the teacher is accountable. Teacher is looking after everybody and monitoring whether everybody is listening my lecture or not. If somebody is not listening, started sleeping, he will give a kind of alert to him, right? Similarly, I want that there must be a small app running on your computers, so that the moment you go out of my scene, suddenly the computer has to generate an alert to you and should send a signal to the organizer that so and so has quit, so and so has disappeared, is no longer sitting in front of the camera, is not listening. Even if somebody is listening, what is the guarantee that he is alert? He may be with a closed eyes, or he may be simply his mobile cell phone, attending his call. If that is the case, the activity has got to be recognized, not that video has got to be sent across the cable. Instead, that activity information has got to be sent across. Then don't you think that the congestion of the network can be reduced to possible minimum and system can effectively work? Then nobody is really required to watch your continuous videos being displayed on the big screens. Instead, all computers are actively working, individually working. That's what I said in the beginning, called edge computing. Today, there is a big research, there is a demand for edge computing based solutions, because edge computing is the only solution which could speed up your machine learning activities. So, expression identification really finds interest. Are you happy listening my lecture? Are you unhappy listening my lecture? Are you sad? Are you angry? Right? What is your mood? Can I analyze that? Yes, instead of me looking at your video, I want computers itself looking at you and then not sending the entire video, but sending only that reason, only that uh, knowledge generated out of that. So look at, here is a boy who very, very alert, attending the lecture online. Look at, here is a boy sleeping. Then computer has to send not the video, telling me that he started sleeping at 10 o'clock, right? And he continues sleeping even now after 1 hour. So here is, see, instead of getting these displayed, I want only some dashboard which gives me an alert telling that so and so has just started sleeping, so and so has come back, so and so is happy listening you, so and so is finding difficult to understand your lecture, so that I can reproduce my lecture, right, in a different style with a different set of examples. So this is another interesting application which I explored as part of demo technology, where we wanted to deploy our face recognition model for very big, uh, retail shop, especially retail shop. So the retail person wanted to know whether this person has visited second time or not. There was nothing like if anybody face which was given for training. Whoever enters, his face information has got to be recorded. And one or the other day down the line, next day or day after tomorrow, if the person comes on the same day, next 1 hour, if the same person comes back second time, then it is guaranteed that he has come back to buy something in my retail shop. Otherwise, he would not have come second time. First time, casual visit, he wanted to see and compare against items available in other shop. When he has gone out and has watched some other items, has come back means he has made some decision. Now, if I can give him a convincing answer, probably I can see that he will buy something. I have some business, right? So then my interest always goes towards finding out quickly the person who made second visit, who made third visit, or somebody who happened to be my old customer has come into, has visited my shop and bought some item last year in the month of November. And he has come back again in the beginning of November this year. That there is some anniversary celebrations. He has come, and last year he has purchased so and so item. Probably he will look for something associated item, right? So that I can show him all such quality items of that level only, of that related, right? So I want the system to tell me and instruct me that, look, so and so has come back second time, so and so has come back third time, so has visited, last year and come visited again the same, almost same week of the same month, and so on. And there are thousands of people coming in and going out. If that is the case, how do I build up my library? Then I have got to think of hash function, which clusters all similar looking faces together and push them into some bucket, so that when the new person comes in, the respective bucket will be identified and the face biometry will be searched for that to speed up. This is a wonderful application which we really faced and solved as a challenging problem. So social distance violation because of COVID-19, right? We worked on, look at here is a drone captured video of Bangalore city. This is a real data I am presenting you. This is a drone captured video of Bangalore city. Look at here is vehicles are identified, trucks are tracked, and people who are identified. Look at social distance violation is there because people are walking with so close to each other. So identify the person, detect the person, calculate the distance, and then decide whether social distance is maintained or not, and so on. This is a real-time data which we captured with the permission of police people in Bangalore city using drone camera. So this is another where crowd dispersion and crowd detection is executed. This is also video analytics of real-time data. Okay, so similarly, cough detection we worked on as part of industry to produce powerful, COVID-19 supportive product, and we also worked on COVID-19 chest X-ray image classification and so forth. Other challenges are many related to COVID-19 and taking up attendance of employees of retail shop. That's what I explained. Similarly, you can think of taking up attendance of students in a class. It's not that you have to click a picture when students are seated. While students are entering into classroom itself, there must be a video camera. Camera will capture the video, and then the person will be recognized, and attendance will be automatically marked. So this you can think of detecting faces when background light is too bright. Now my face is, if not clearly visible, reasonably good on the video. But if I keep some background light here on continuously, in case if you see instead of this, Almera, if you have some window where light rays are coming inside, my face will be with shadow. So then face recognition is not possible. In that case, how do I enhance the picture so that the face becomes more clear, right? So if it is a glass door, then most of the times instead of recognizing people who are inside your hall, you end up recognizing the people who are standing outside that. If there is a glass door, right? People are standing outside in the footpath, but the shop camera will recognize even the people who are outside that door, right? Then how do I classify the people standing outside the door from the top people standing inside the door when the door is of glass material, right? So these are all quite interesting real-time, challenges. So recognizing royal customers while entering shop, like district commissioner who has been posted now recently into my district will step into my office. The moment he steps into my office, though he is coming into the scope of the camera first time, because he is a royal customer whose face is available on the Google, and there is a notification from the government of Karnataka that so and so has been posted, automatically I want system to recognize him, right? These are all things where you can take up and see that you also contribute for reality. Look at, because of background light is so bright, the face is not so clearly visible. How do I? This is an entry activity. This is not an entry activity. This is an exit activity. This is quite simple. This is where we brought in RNN. I mean, so door is at the time of assume that you are watching inside the hall, and when somebody wants to enter into the hall, then door step by step getting open. I mean 10 degree, 20 degree, 30 degree, etc. You train CNN to generate this degree first. If the CNN can generate 10 degree, 20 degree in sequence, okay, then RNN will look at that sequence and classify that it is an entry activity. On the other hand, if the CNN generates the 80 degree, 70 degree, 60 degree in reverse, right? Then our RNN can recognize that it is not an entry, it is instead an exit activity. Look, you can think of combining, CNN with RNN so that activity detection is possible. So we have worked on quite interesting such, activity detection approaches to productize, to materialize a product. So this is where we've also worked on some shuttlecock face recognition. Sometimes especially we created for fall detection and people making crowd and supporting. Right? If something happens, then the system should generate an alert to the owner of that sport stadium, so that person can come and attend to this person and so on. This is, and sometimes intentionally people will hide the camera because he wanted to do something which is not acceptable, and because the environment is completely surveillanced by camera, then before he commits any activity over there, he wants to hide the camera kerchief by any other paper, right? If that happens, then the system should automatically generate an alarm, right? That's another quite interesting application. So probably you see here. See, if somebody is disturbing, then alert should be generated. You can see what is this? Obscuring the camera, right? Nothing is visible. Then the resolution may go lost. The system should immediately generate an alert to the owner, so that owner can come and look at this situation. Okay, personal protective equipment detection, because in most of the industries, when there is a dangerous area, people are not allowed to enter without any safety, equipment. One has to go with a helmet and so on, right? So this is another look at. This is quite interesting for you, I am sure. Observe this person with a blue color dress. He is trying to climb up. See? So due to some, see, it's not that my interest is to detect that activity happened. Before it is happening, I wanted the system to automatically generate the alert. Had there been somebody who is watching this man climbing up, then he must have instructed him that be careful, it may happen like this. You may fall down, right? Similarly, I want the system to give him an alert. Be careful while climbing up, hold your hand, and so on. That is what is the application of machine learning. I know deep learning for video analytics, for safety equipment, automation of number plate recognition. Look at the density of the vehicle in this, Bangalore traffic. Even counting of vehicle is really tough. In that case, recognizing number plate of each vehicle. How is it possible, right? See, not only that, and we also worked on the problem related to what if anybody violates a traffic rule, like actually there is a track here, there is a line here which separates this area from this. So in this area is reserved for heavy vehicle. This area is reserved for heavy vehicle, not for any two-wheeler, not even for for cars, only for buses and lorries. But these people are violating that rule. Then the system has to recognize the number plate and send an email to these owners, looking at their email ID enrolled at the time of buying the car in RTO, right? And send an email so that they can report to the court and pay the penalty, right? This is what the problem is, right? So how to recognize? Look at here. So this is on recognition of number plate. If I stop at some junction, see what is generated is a number plate. The number recognized here is displayed. So it's that you have to take hours together to recognize. The system has to recognize on real time, right? As in when car is moving up, by the time it crosses the scope of the camera, the number has got to be recognized. In addition to that, the make and model of this car has got to be recognized. All should run parallelly. It's not one. I want the number plate to be recognized, and then I want make of the car to be identified, model of the car to be identified, right? And if there is any violation of traffic rule, that has got to be recognized. Doesn't mean that there are multiple cameras and multiple systems working. I want everything to be re-engineered into an aggregated solution, an assimilated solution. That is the real demand, current requirement for making AI in reality possible. So this is one more interesting application which we worked on. Let me show you. So look at this. Here is barricade where there is a gate, the before trucks enter, the trucks people have to take a permission and then enter. Because for every vehicle the person takes up some time, then queue gets formed. Then the question is, at an instant of a time, how many vehicles were on queue? What is the dwell time of each vehicle? What is the waiting time of each vehicle? That has got to be automated. Okay. So then truck detection, there is a like SSD, right? They like YOLO. There are vehicle detection algorithms, deep architectures available. If you deploy them, then even these vehicles get detected. Even these vehicles get detected. Look at this. Though it is very used lorry, very used truck, that doesn't get detected because it's not the truck which is trying to enter into this gate. Then how do I classify? How do I know which vehicle is trying to stand on the queue and which vehicle is passing through the adjacent lane, right? That is what I said, personally tailoring. You cannot deploy as it is available deep tool, right? Deep architecture. You have to personally tailor it up so that it ends up detecting only the vehicles which try to pass through this gate. Number one. Number two, when you to calculate the dwell time of a vehicle, you have to continuously track the vehicle. But unfortunately, due to real environment and there are sudden shakes in the vehicle, you may lose the tracker. When you lose the tracker, you have to reinitialize the tracker. When the reinitialization happens, tracker will have a different ID. Then for a single vehicle, the system ends up generating multiple. Then how do I identify that? These are all the generate for the same vehicle. I mean, you have to generate the equivalence class of IDs. This is really a wonderful, the topic which we worked on as part of our industry assignment. So look at the equivalence classes. There was a tracker ID 0 and tracker ID 1. Both of them got generated for the same truck. That doesn't mean that tracker IDs are always in sequence. Look at here. This is 2 and 5 are equivalent. I mean, tracker ID number 2 is given to some vehicle, but tracker was lost. Again, the vehicle was identified, but with a different tracker ID 5, and then 5 was identified to be equivalent to tracker 2, ID 2. Look at 7, 8, 12 were identified to be same. Then, so all being the same, then at what frame the truck has entered, like 191, at what frame the truck has exited, what is the difference in the frames, and divided by, take the difference and divide it by the frame per second, right? FPS of that video capturing, that gives you the total dwell time. The dwell time is about 69, right, seconds. The dwell time of this is about 34 seconds and so on. This is what is supposed to be displayed, not the video on the dashboard. Not the video on the dashboard, only the. Hope you are understanding that. Okay, that is a real challenging issue. Okay. So this should not be identified. Only these trackers. Look at, you can notice that 4 continues to be 4, right? 6 suddenly shifted to 8, right? 7. And you must have watched that, you must have watched that. There was a truck coming in. See, here's a truck, still it is not identified. See, now it is not identified still because not sure that comes to the same lane. Then the moment it is assured that it comes to the same, even not now, it got detected. How to tailor it up, how to personally stitch off the available deep architecture. That could be an interesting research topic for you people to explore further, right? So we worked on flower classification, that's I mentioned in the beginning, and visual quality of product, agricultural product, classification of fruits, and detecting internal defect inside, not and so on. You must have seen in the apple, some soft black, some soft tissue is inside with black in color, so that apple is not eatable. But when you look at apple outside, that's not visible. So you will understand that apple is good. But the moment you carry it home and then cut it off, you will notice it. So while buying it, if I keep my mobile, then mobile has to say, don't buy it. There is some internal defect inside. That doesn't mean that you can subject it for X-ray, right? Because any food product which is subjected for X-ray is not advisable for eating, right? So generally we should not expose it to X-ray. Instead, we have to use a different, rays and identify. That's what we also worked on that. So there are many challenging video applications like sign language understanding, classroom attendance, signature verification, traffic signal alert system. Really challenging topics for you people to explore. And we have been working on these topics for the last roughly about 2.5 decades in our Department of Studies in Computer Science. We have a specialized lab called Data and Learning Lab. Okay, so you people for a short visit can come and stay with us, work with us, get your problems solved, publish 1 or 2 papers based on our supervision, and cite our, acknowledge our support or major contribution from our side. You can have a co-authorship, but you have to manage your, expenditure to stay in our. But we will provide you an office and system to work and so on. So if I sum up my lecture, friends, I started up explaining you the fundamental science behind AI, ML, and DL, and narrated the challenging issues associated with face recognition in real time and activity detection related and personal protective equipment, safety for some, highlights on automation of number plate recognition, queue count of vehicles, and dwell time calculation. How did we personally tailored up, deep learning architectures to make applications practically feasible, right? So that's what all in all. So with this, let me just acknowledge the organizers of this program for having extended a kind of invitation to share my experience in this field, which I could gain because of my personal research and also because of research carried out by more than dozens of research scholars over the last roughly 20 plus years. So I must also thank my research students and my industry, data scientists who helped me in preparing these slides and presenting this, who have given me a rich knowledge and made me an experienced person to talk continuously without any break on any topic related to video analytics today. I thank one and all for your patience listening. With this message to all you in ಕನ್ನಡ ಸಂಶೋಧನೆ ಸಂಯಮದಿಂದ ಕಲಿಕೆಯಲ್ಲಿ ತೊಡಗಿ ಶೋಭೆ ತರುವಂತಹ ಜ್ಞಾನಾರ್ಜನೆ ಗಳಿಸಿ ಧನಾತ್ಮಕವಾದ ಯೋಚನಾ ಲಹರಿ ಸಮಾಜವು ನೆನಪಿಸಿಕೊಳ್ಳುವ ಆವಿಷ್ಕಾರ ಮಾಡುವಂಥದ್ದು. I mean, you have to work for something which the society remembers for your contribution. While working so, be with a positive mind and have a great patience to acquire such a great knowledge. That's what I understood called research. Thank you one and all. Thank you very much for your patience. Over to the organizers, please.
Yes. Thank you, sir. Thank you very much for your excellent keynote talk.